Okay, so this one's asking me to find sine of arc cotangent of 2x. So when we have these compound trig problems, where you have a trig function inside of another trig function, we always start with the innermost trig function first. So we're going to start with the arc cotangent of 2x. Now remember, all of my arc trig functions, or my inverse trig functions, they take in a ratio of sides and they give an answer that is an angle of measurement. So right here, this value is supposed to be a ratio of sides. Because it is arc cotangent, that would be the ratio of my adjacent over my opposite. Well, they don't give me the opposite side, but I can always put any number over 1. That way I now have an opposite and an adjacent. Excuse me, I have an adjacent and an opposite because it's cotangent. So I know that I have the adjacent side and the opposite side. I also know, because it's arc cotangent, that is defined for the first and the second quadrants. And because the argument is positive, that means I have to be in the first quadrant. So the way I think of it is I have a triangle in the first quadrant where the adjacent side is 2x and the opposite side is 1, because we're looking at arc cotangent, which is the adjacent over opposite. So I don't know what this angle of rotation is. It's not one of my angles that I have memorized, 30, 60, 90, or 45, 45, 90. So let's just call that angle that I rotated to get there theta. Now, I know two sides of a right triangle. I can use the Pythagorean theorem to find the third side. A squared plus b squared equals c squared. So in this problem, what I'm missing is my hypotenuse, which has to be the c. So let's let a be 2x. Let's let b be 1. And now when I carry out the math there, I'm going to get 4x squared plus 1 equals c squared. And so to solve for c, I would take a square root of both sides, which tells me c is equal to the square root of 4x squared plus 1. So what have I just found? I found my missing side of this right triangle, which would be 4x squared plus 1, all underneath a radical. So again, what was I doing with this problem to start with? I was taking this inside trig function, which was arc cotangent. It takes in a ratio of two sides, and it gives an answer that is an angle. I actually did not know what the angle is, but what it would report back out to be is this theta. So the arc cotangent of 2x over 1 is this angle right here that I have drawn. So whatever the angle is, just because I don't know the specifics, I can still call it theta. And so now I'm wanting to find sine of that angle. Find sine of that theta. So in this example, we know sine from this angle would be the opposite over the hypotenuse, which would give 1 over the square root of 4x squared plus 1. And now I'm pretty sure on EasyBridge, I'm sorry, y'all don't do EasyBridge. That's my geometry class. On your My Math Lab, it's going to take the answer like this, where we did not rationalize the denominator. Okay, so this would be an acceptable answer. Or if you did rationalize the denominator, that would be multiplying by radical 4x squared plus 1 on top and bottom. I would get the square root of 4x squared plus 1 all over 4x squared plus 1.